Hi everyone, this is Matthew Carter, Keysight Solution Partner Account Manager, and I'm here with Wade Loudermilk, the CTO of TEVET, and he's going to be walking you through the Liberty real-time spectrum analyzer and how to initiate multi-channel RF recordings. Wade?
Hi, I'm Wade Loudermilk, and today what we're going to look at is what we refer to as the AXIe hybrid Liberty platform. And we're going to be showing you the multi-channel real-time spectrum analyzer. A quick overview of the hardware. It is a hybrid configuration. It has the Keysight AXIe modular platform. And in this here, we have a 4-channel digitizer and a 2-channel arbitrary waveform generator. So we are digitizing the data in the AXIe platform and then streaming that data to the PXIe platform into our FPGA real-time processors for each channel. And if you look at the PXIe chassis, you can see that the data flows into our FPGA module where we're performing our real-time processing, and then we stream optically over to the conduit Cobra modules, which consist of an optical interface and a 16 terabyte solid state RAID. Each channel has its own FPGA module for processing and the Cobra modules, and we're running all of this in parallel. If you look at the application, so we have the real-time application running right now. It consists of, in the upper left, this is your spectrogram. In the upper right is the histogram. In the lower left is our spectrum plot. And then over in the bottom right is the time domain plots for each channel. Before we get into the details, I can show that we've got this set up that if I just come up in this circle up here and I just select it, it captured the data. And we'll talk about that in a little bit. When you look at our graphical user interface, in the upper left are system level controls. This is an arming function, which is the circle. The wrench here is where you would set up the individual channels, which we will talk about later. In addition to that, if you end up getting off in some area that you're not sure, we actually have a default tab that if you select the default tab, it will take that back to an original state. Next to it is the ability to switch between local control or remote control. Our applications have an application programming interface that's compatible with C, C++, Python, MATLAB, and obviously LabVIEW. Next to that is a lock where you can configure the instrument, and we'll see that in a minute, to be totally independent. So each channel is totally independent, or partial independence, which I'll describe later, or totally dependent. And totally dependent means all parameters are identical for each channel in this system. Above that to the right, which you can see, are a set of parameters, and it's giving you the status. The first column is giving you what we refer to as the capture parameter status. Next to that is the analysis parameter status. We also talk about the number of FFTs that we can perform. That's per frame, per second. We also compute what the Tmin is, which is an important parameter in a real-time spectrum analyzer, which basically tells you what is the minimum pulse width that this RTSA can detect at full accuracy with 100% probability of detection. And we'll look at that in a little bit. And then we get into the window information, and the last column is about the record data. So it's giving you status on the record parameters. If I come, and keep in mind, I have 4 in this configuration. I have 4 real-time spectrum analyzers running at the same time. In this GUI, I can come into the spectrogram, for example, and I can choose which channel I want to visualize on the spectrogram. In this case, we're doing channel 0. I can come over to the histogram and be able to select which one of the channels that I want to visualize. The important point here, all 4 are running at the same time. All 4 can be configured, and we can then visualize which you want to look at. In the lower right-hand corner, that is recorded data. I showed that earlier. We'll talk about that when we get into how to set this system up. This is an intuitive system. It is identical in terms of the record capabilities to our multi-channel RF record application. To get into the to control, basically select the wrench. What happens is you get a control field that pops up. You have all 4 channels here where you can configure the capture parameters and the analysis parameters. For our real-time spectrum analyzer, we have decoupled the capture parameters from the analysis parameters. And the reason that we do that is that we are able to improve the minimum detectable signal by decoupling the capture from the actual analysis. When you set up the capture, it wants to know center frequency, bandwidth, and sample rate, and reference level. That is identical to our RF record application. When you set up the RF record application, you give it those 4 parameters. And so that is what the capture is set up. I can do that for channel 0, 1, 2, and 3. The analysis parameters, you have to also set up its center frequency, its analysis bandwidth, and you can also come in and control the display level. You control the resolution bandwidth, you can control the windowing, so it's basic spectrum analysis, so we give you the ability to control that. And that is on the RF tab. If I move over to the record tab, and I go to setting up the record, this control field is identical to what you would see on our RF record application, to where you give it the file name that you're going to stream to, you give it the pre-trigger information, the post-trigger information, and the duration. And what that means is that we essentially set up this circular buffer such that when you arm the record application, what it'll do is it will essentially capture data prior to the trigger, and then you're able to stream either up into DDR, depending on the mode, or to solid state RAIDs. From a triggering perspective, when you set up mode, it'll ask, do you want to do snapshot mode or contiguous mode? So you have the ability to control that. If I go to the trigger, here I can select the trigger for each one of the channels. What we have are, you can do free run. And free run means that's a software keystroke. You set this up and you basically just hit a key and it'll start the recording process. Or you can do time domain. Time domain can be set up to be either threshold, rising edge, or falling edge. We also have frequency mask triggering capability, frequency density triggering capability, and you can also have external, which means that you can have an external trigger come in from an outside source. We will sense that trigger and then start the recording process. And you can set that up for each one of the channels. So that's an important point, because I could set up channel 0 to be frequency mask. I could set up channel 1 to be frequency density, channel 2 to be a time domain, or channel 3 to be an external. That allows you to be able to use different types of triggering for the record process. If I come over, I can also control the spectrogram, which is in the upper left. I can control its sweep period, the number of frames that are displayed. I could also select this frame that allows you to come in. In addition to that, I can control the type of detector that you use in the system. You have 2 choices. You have interval peak and interval average. Depending on what your application is, you would choose one versus the other. In addition, I can control the color schemes of the spectrogram, and that's a user preference type of a thing. If I move to the histogram, in the histogram, you're able to control what was referred to as the granularity. That is essentially the observation time when you're performing the actual measurements. I can turn on and off smoothing, which is to make the graph look prettier, basically. And I can control the persistence, the emphasis, and the saturation. If I have generic settings here, all of our applications have this capability that once you set the instrument up to your preference, you can then save that into a file to where if you come back later, you can recall it, the instrument will automatically set to those preferences. If I then come out of that and go back to the instrument here, basically from a record standpoint, it is straightforward. We've chosen just a software trigger. That's the ARM function here. Boom, I just recorded data. We have it set up in snapshot mode. And so it just grabbed data and then it displayed that data. So that is an overview of our multi-channel real-time spectrum analyzer.
Awesome. Thank you, Wade. If you'd like more information, a demonstration, quote, or other technical information, please go to tevet.com and search for Liberty. Thank you.